Today we are going to be doing lesson 4.1 and 4.2. We're going to combine them together because 4.1 is just a review on the coordinate plane. And then in 4.2 we're actually going to use the coordinate plane and we're going to graph equations that are lines, okay? First of all, let's look at what the coordinate plane is. Now, at some point in pre-algebra or Math 7 or Math 6, whichever one you took, you should have seen a coordinate plane, all right? A coordinate plane has two different lines, and one of them is the x-axis and one of them is the y. We always know that the horizontal line, the one that goes left to right, is our x-axis. Right here we have it labeled our x-axis. And the one that goes up and down, or vertical, is our y-axis. Now, each of these lines represent values on a graph. Now, these grids right here tell us how much those values are. So it would be 1, 2, 3, 4, because we know all the values to the right of the y-axis when we're dealing with the x are positive. So that means all the values to the left are going to be what? Negative. So -1, -2, -3. It's like you're dealing with a number line, and the y-axis is your 0 or origin, because that's what it is. And then when we do our y-axis, it's like we're dealing with a sideways number line. All the numbers above the y-axis are what? Positive. And all the numbers below are negative. Think of it as a ladder. Everything above is positive, everything below is negative. Okay, and from there we can use this coordinate plane to graph all sorts of things. We can do lines, we can do circles, we can do ordered pairs, just points. We could do parabolas. We're going to get into all kinds of graphing stuff. But for chapter 4, we're only going to stick to graphing lines and ordered pairs. So just points or points that make up a line. So let's talk about ordered pairs first and how to graph them. First of all, the ordered pairs that we see here are all listed right over here on the left-hand side. How do I know an ordered pair is always written? What letter always comes first, Clay?
X.
X, comma, Y. That is always how my ordered pair is written, and it will never be anything different, okay? So what they want us to do is they want us to draw a coordinate plane. Now, you're either going to want to draw this on your graph paper if you have it out, or you can just draw it on your notebook paper if you don't have any graph paper with you today. Okay, I went ahead and numbered my graph so that we could graph these ordered pairs. Now, remember, an ordered pair is x, comma, y. So what you have to know is each of these numbers does not represent a point by themselves. Like, we're not going to put a point at 4, and we're not going to put a point at 5. We're going to put a point at 4, comma, 5. So that means I've got to look at each of these values and determine where they're going to fall on my coordinate plane. So the first one that I'm going to go is I'm going to go to +4 on the x-axis, because we know that the first number is always x. So I go over to +4, and then I'm going to go up to +5 because my y value is +5. So there's my first point, just like that. Okay, let's do the same thing for the next one. We've got 2, 0. So I'm going to go over to 2 on the x-axis, but y is 0. So am I going to go up or down at all? No, because it says it's 0. I don't move anywhere. There's my second point. -3, 8. -3 on my x-axis. So this time I'm going to go to the left to the 3 because it's a negative, and then up to +8. Here's my next point. Next time I'm going to go to -7, -6. So I go over to -7, down to -6. Right there. And then last but not least, I've got 0, 9. So if x is 0, I stay right there at the origin because I don't move left or right any because it's 0, but I go down to -9 and it's right here. Now, these are just ordered pairs that they wanted us to plot. we in no way will ever connect these. So don't think, oh, I got to make a line. I got to connect the dots. How in the world is that going to work? It's not, because it's not what it's meant to do. They just wanted you to plot these points to get a feel for, okay, this is how we use our coordinate plane again. Okay? So next thing, they want us to work in reverse order. They've given us the points, and they want us to write the ordered pair that they represent. So let's go ahead and let's do that. Let's look at A. What is the ordered pair that represents A? Matthew?
-2, 4.
-2, comma, +4. Perfect. We always write our x value first. Now you say, okay, I'm not quite sure how you do that. Here's a really easy way to do it. Find point A. Draw a line straight down so you run into the x-axis. What number are you going to run into? -2. So we write that as our x. Draw a line straight over to the y-axis. What number do I run into? 4. So I know that's my y value. Okay, B. Darius, what ordered pair represents B?
3, 1.
3, comma 1. Perfect. C. Clay, what ordered pair represents C?
C,
-1,
-5.
Very good. -1, -5. Jacob, what ordered pair represents D?
6, -2.
6, -2. Perfect. Morgan, what ordered pair represents E?
0, 2. No.
2, 0. Very good. Now, okay, she got a little bit confused on 2, 0 and 0, 2, which happens to a lot of people. But look at this. What axis did the dot actually move on? The x. Do you see how it's on the 2 on x? So I know the 2 has to go in the x spot. We did not move up or down at all, so that's how I know that it goes in the 0 spot. So Jasmine, what is F?
-4, 0. Oh yeah, 0, -.
0, -4. Perfect. Again, she made the same mistake, but she corrected herself. We say, okay, did it move along the x-axis at all? Did it move left or right? No, it stayed right here at the origin. And then we went down -4. So that's how I know it's 0, -4. Okay? That is our review of the coordinate plane. So we're going to move on into 4.2. So in lesson 4.2, we're going to actually graph linear functions. Now, linear, what do you think that that's going to represent? A line. Very good. Now, before we even get into that, though, we're going to verify a solution. So we're going to take equations, and I'm going to take an ordered pair and say, yes, it is a solution, or no, it's not. Before we do all that, let's talk about these equations and these ordered pairs. On the first slide right there, I just said we're going to be graphing linear equations. So what this equation represents is a line. Every equation that has an x and a y represents a line, or some form of a line, I guess I should say, because we'll get into different ones later on in the year. But it represents a line in this case. So what I'm finding is if this ordered pair is a solution, what that means, like for instance, if I were to graph the line, and let's say this is my line, if the ordered pair is a solution, then that means that point that the ordered pair represents actually is going to fall on the line or end up on the line. If it's not a solution, that means that our ordered pair or our point is somewhere outside or off of the line. So that's what we mean by yes or no. Because let's think about it. What letters does an ordered pair represent?
X and Y.
X and Y. Look what letters we have in our equation, X and Y. So do you think I need to actually graph the line and then graph the points to find out if it's going to be a solution? No. We can just substitute or plug in the numbers for the variables. It'll make it much easier on us. Now, they gave us 2 ordered pairs here. Oops. They gave us 2 ordered pairs. So what I need to figure out is if one or both are going to be a solution. Just because one is yes does not necessarily mean that the second one will always be no, or maybe vice versa. They both can be yes and they both can be no. So we always have to do both ordered pairs to find out. All right, so let's plug in our first one. First of all, what does that 1 represent in this first ordered pair? X. What does the 2 represent? Y. So let's plug it in. We have 1 plus 3 times 2 equals 6. Solve it down. Remember, show all work. You're probably going to want to get out your calculator just to make sure you don't make any mistakes. 3 times 2 is 6. 1 plus 6 is 7. Does 7 equal 6?
No.
No. So we know that it is not an ordered solution, or the ordered pair is not a solution, excuse me. So now let's try the next one. Let's see if the next one works out. We have negative 3 plus 3 times 3 is equal to 6. Follow order of operations here. 3 times 3 is 9. What's negative 3 plus 9? 6. Does 6 equal 6? Yes, it does. There's our answer. All right, I want you to do this next one on your own. Tell me yes or no. Okay, let's see here. This first equation, Morgan, I want you to plug the ordered pair in for me and tell me yes, it is a solution or no, it's not. And walk me through how you did it.
Okay, so you would do, replace the x with 1, so it'll be 4 times 1, plus 4 equals 8. Then you multiply 4 times 1, which is 4, plus 4 equals 8. And then 4 plus 4 equals 8, so 8 equals 8, and it's the solution.
Very good. So our answer is yes. All right, Clay, walk me through the second one.
Oh, you have to put in the 3 and the 4, so it'll be 4 times 3 plus 4, which equals 16.
Okay, how did you get 16? What did you do first?
Multiplied 4 times 3,
Very
and
good.
then you added 4. And 16 is not equal to 8, so no.
Very good. Now remember, make sure to show all your work. Very good. So we got yes and no. Now, like I said, these actually just worked out so that one was yes and one was no, but that won't always be the case. Sometimes they'll both be yes. Sometimes they'll both be no. So make sure you work every single one out and don't just write a yes or no. Okay? In order to graph an equation, we have to have it in function form. Well, let me back up. There's several different ways to graph an equation. In Chapter 4, we're going to learn 3 different ways to graph an equation. The first one we're going to learn today, and that is by using a table of values. Then tomorrow, we're going to learn how to graph using x and y intercepts. And then later on in the chapter, which will be on our next test, we'll learn how to graph using slope-intercept form. So in order to graph making a table of values, there are 3 steps that you have to follow. Step 1 is rewrite the equation in function form. Well, guess what? Remember in Chapter 3 when we were solving equations and writing them so that y was a function of x? Remember how I made you get y by itself? And then I made you say that, oh, the x has to come before the number by itself. So, for instance, we would have an equation like y equals 2x plus 5. Do you remember that? That is function form. You all already know how to do it. That's why I taught it like that in Chapter 3, so you wouldn't be learning something new now. So, for instance, if I were to give you this equation right here, 2x plus y is equal to 3. What would you do in order to get this in function form? What would I need to do, Madison?
You would try to get the y by itself, so you would subtract 2x on both sides, and your answer is y equals negative 2x plus 3.
Perfect. We subtract 2x on both sides, move it over so our y's by itself, and then when we rewrite the equation, that negative 2x has to come before the 3 because our x value always has to come before the last term, or our constant, if you will. All right? So, step 1, done. It's written in function form. Step 2, make a table. Here are 3 values that I always want you to use. Now, these 3 values will probably differ between the different teachers that you have. Some teachers like you to have 5 numbers. Some teachers want you to have 3. I am one of those people who just wants 3. I think we can get a good representation of the line without having to do 5 different points, okay? But these are always the numbers I want you to use. We're all going to use the same ones. That way, I know, okay, yes, you understand it, or no, you don't. And on a bonus for me, it makes it a little bit easier if everybody has the exact same equation, if you don't just use random numbers, okay? So let's make an X and Y chart. X, Y. The X values they want me to use are -2, 0, and 2. So all I need to do now is plug it into the equation and solve for Y. So I would write Y is equal to -2 times -2 plus 3. Y is equal to 4 plus 3. Y is equal to 7. So there we go. I have my first ordered pair, -2, 7. So when I go to graph, I know what to graph there. Then I'm going to plug in 0. -2 times 0 plus 3 is 3. Then I'm going to plug in +2. -2 times 2 plus 3. Y is equal to -4 plus 3. Y is equal to -1. So there we go. Now I have my 3 different ordered pairs. I could set up my coordinate plane and I could graph my line. Now we're going to actually do that on the next slide when we use an actual example. But I just want to show you the form or how you would do things in order to get up to graphing your line. Okay, so there's 3 different steps. Put it in function form. Plug in the values and then graph the line. Okay, so let's put that into practice. First of all, what would be step 1 here?
Write the equation in function form.
Very good. Write the equation in function form. So, Javen, what does that mean I need to do first?
Subtract 2.
Perfect. Subtract 2 on both sides. Now I have y is equal to 3x minus 2. Step 1, done. It's in function form. Step 2, what am I going to use in order to graph?
I know.
X and Y chart. Whoops.
It's a really long.
Okay, X and Y chart. So I'm going to use what values for X?
-2, 0, +2.
Very good. All right, let's plug it in and let's solve. All right, let's plug in -2 first. So I have y is equal to 3 times -2 minus 2. What's 3 times -2? -6 minus 2. What's -6 minus 2? -8. Very good. Same signs, add and keep. Now I'm going to do the same thing but with 0. I have 3 times 0 minus 2. Well, what's 3 times 0? 0. So y is equal to -2. Then last but not least, +2. Y is equal to 3 times 2 minus 2. What's 3 times 2? 6 minus 2 is 4. So now I have my 3 ordered pairs and I'm going to use my coordinate plane right over here to graph them. I'm going to go ahead and write my numbers on my coordinate plane so I know exactly where I'm graphing each thing. Okay, my first ordered pair that I have is -2, -8. So I go over to -2 to the left, and I go down to -8 and put my first point here. Then I'm going to go to 0, so I don't move at all, I stay at the origin, and then I go down to -2. Then I go over to 2 and up to 4. Now, this is different than when we just plotted our ordered pairs, because these are not just random dots. These dots are part of a linear equation, so they should make a line. If you have ever graphed something and one of your dots falls like outside of the line, or you go to draw the line and it's going to have like a zigzag or a curve or something in it, you know you've done it wrong. They should all line up perfectly. So what we're going to do now is we're just going to draw our line through the ordered pairs, and we are finished. Make sure when you draw your line through the ordered pairs, you always extend it through the first and the last point. Never start with your first point and end with your last, because that's a line segment, and that is not what we are graphing. We are graphing a line that extends forever and ever and ever. It never stops, okay? And we have only found 3 points on that line. So that's how we've connected it. So make sure you always extend, because if you start with the first one and end with the last one, you will not get full credit on your test. Okay?
What do you mean?
Okay, I want you to go ahead and work on this one on your own. Work on this one on your own. Okay, Bumnet, what did I do first?
I picked values.
Okay, before you pick values, what are you supposed to do the very first step? Clay?
You have to get rid of the 2 on the y.
Okay, we got to put it in function form. So what does that mean I do?
You have to add 2.
Add 2 to both sides. Very good. And now I get what? Amanda?
Y equals 5x plus 2.
Very good. Y equals 5x plus 2. All right, Alex, what do I do now?
Now you,
X and Y chart. Very good. All right, Javen, what numbers am I going to use for the X and Y chart?
You're going to use -2, 0, and 2.
-2, 0, 2. All right, Morgan, when I plug in -2, what does my equation look like?
Y equals 5 times negative 2 minus 2.
Plus 2, because remember we moved it over, okay? Megan, once I plug that in, what do I get after I solve my first step?
You get -10 plus 2.
Very good. And Darius, what is my first answer? -8. Very good. Okay. Let's do the next number. Stephanie, when I plug in my next x value, what does my equation look like?
Y equals 5 times 0 plus 2.
Very good. All right. Naomi, what do I get as my answer then?
For what?
For this one right here that we're doing. 5 times 0 plus 2.
2.
Positive 2. Very good, because 5 times 0 is 0. So I get 2. All right, Anna, plug in my next value for me. What does my equation look like?
5 times 2 plus 3.
Very good. 5 times 2 plus 2. All right, Matthew, what do I get after I work that for the first step?
10 plus 2, but that's 12. So
Okay, so y equals 12. Very good. Okay, Madison, once I do all that, what am I going to do now?
you are going to graph.
Graph. Very good. Okay. Jasmine, where do I put my first point?
On the -2 on the x.
Very good. -2 on the x, and then where do I go?
Go down -8.
Very good. Over to -2, down to -8. Jacob, where does my next point go?
You stay at the 0,
Mhm.
and then you go up the negative up 2.
Up 2. Very good. All right. Bomnet, where's my third point go?
The x-axis go to 2,
Mm-hmm.
and then you go up to 12 on the y-axis.
Very good. Now, I had to extend my graph here because I did not have enough lines, which is fine. Okay. Now, let's see here. Matthew, what am I going to do now?
Draw your line.
Draw my line. What does my line have to do? Extend through the points. Very good. You want to draw the little arrows on the end so we know that the line keeps going and it does not stop with the first and last point. Okay? Okay, now what happens when I have an equation that looks like this? What am I going to do? How do I graph it? Actually, it's very, very simple. Do I have, first of all, an equation that I can put in function form? No, there's just a variable and a letter. Do I have an x that I can even plug in the 3 values for? No, so there's going to be no work like that. So how am I going to graph? Well, very, very simple here. This is what we're going to do. First of all, I know that y is equal to what? To 2. There's no other value that y can be because y is equal to 2. So whatever variable they give you, that is the axis that I'm going to go to. So what axis am I going to go to? The y-axis. And I'm going to find positive 2 on the y-axis. I'm not going to take the time to put the numbers on this graph, so we're just going to go up to positive 2. So here's my point. Now, I've got to get some form of line out of this because I can't just have a dot. That's not what they want us to do. They want us to graph the line. Well, you say, oh, well, that's easy. It's y, so the line has to go straight up and down. No, not technically. That's not right. What we need this line to do is we need it to cross the y-axis at positive 2 only. So if we were to write our line like this, let's say we wrote it straight down, it's crossing every single y value that is there. Positive 1, positive 5, positive 7, positive 10. You know, it just crosses all of these points. And does y equal any of those numbers? No. So we cannot graph our line like that. All we've got to do here is when you have a y equals, we draw our line straight through the y-axis. You say, that's the opposite direction of what a y usually is. Exactly. It's always going to be that way. Because we want it to just basically cut through the y-axis at positive 2. Because that's what y equals. Okay? So think opposite. If you see a y, you're going to have a horizontal line. So guess what you're going to have when we have an x?
A y.
A vertical line. Okay? So let's look at this. In this equation, y is equal to negative 3. So I'm going to go to my, x is equal to negative 3. I'm going to go to my x-axis, and I'm going to find negative 3. So I go over to the left, 1, 2, 3. Place my point. Now I need my line to cut through the x-axis at negative 3. So what type of line am I going to have?
Vertical.
Vertical. And it goes straight through the x-axis. Okay? All right, I want y'all to do this one on your own. Okay, let's see here. Amanda, what did you do with this first equation?
I put it on, I put like the dot on any one and just drew a line.
Okay, and where, on which axis is the negative 1? Y-axis, very good. And Naomi, what should my line look like that's going to go through that point? Horizontal, very good. Remember, it should not be a vertical line just because it's Y. So Madison, what does that mean I'm going to do with the point that I now have that says x equals 2? Where am I going to go?
You're going to go to the x-axis, and you will find 2, and then you put a dot, and you draw a vertical line through.
Very good. A vertical line through this point, okay? So actually, whoops, I can't draw a straight line. So actually, in order to graph these, it's a lot simpler. There's not even really any work to show at all other than you putting the dot on the line or on the graph and drawing a line through it. Okay? This is your homework for tonight. I want you to go ahead and get started. We're going to do it on the same exact homework paper. So you don't have to break it up into 2 different homework papers. Like you don't have to do homework 4.1 and then homework 4.2. Put them on the same piece of paper. Okay?